All right, so we're going to continue talking about solving inequalities. We're just going to add some steps to it and talk about one little trick that we have to be careful of when we're multiplying and dividing to help isolate the variable. Okay, so we're going to be talking about using multiplication and division to solve an inequality, and we're going to add a bunch of steps. So, and again, the good news is a lot of this stuff is the exact same thing that we did when we solved equations. So hopefully that's makes this a little bit easier. So first example here, x over 3 is less than negative 2. And we're going to, in order to undo that division, we're going to multiply both sides by 3. And so x is less than negative 6. Okay, now to graph that, we know. Then we put a 0 here, negative 6 here. We need an open circle on negative 6 because negative 6 is not a solution, right? The inequality is not equal to. Negative 6 is not less than negative 6. So it's not a solution, but all of our solutions are actually less than 6. So we want to shade to the left. And the same thing here on number 2. We're just going to divide both sides by 4 to undo that multiplication. Oops. And get x is greater than or equal to 5. And so we're going to plot 0, plot 5. Now we need a closed circle on 5 because 5 is a solution now. If you plug it in for x, you do get 5 is not greater than 5, but 5 is equal to 5, so we're okay there. And then the rest of our solutions are going to be the ones that are the numbers that are bigger than 5, so we need to shade to the right. Okay? Not a big deal. Now, the big deal happens when we divide by a negative. If we divide by a negative, right, and we don't flip the inequality sign, we would get here x is greater than or equal to negative 4. And if we were to graph that, we'd go 0 here, negative 4 here. We need a closed circle on negative 4 because negative 4 would be a solution because negative 4 is equal to negative 4. And then the inequality sign that says that we would need to shade to the right, which means that we're shading 0, which means that 0 should be a solution. Well, let's check this out. If I plug in 0 for x, I've got to multiply negative 6 times 0, which is 0. And so I'd get 0 is greater than 24. Is 0 greater than 24? No, it's not. It doesn't make any sense. So what we discover is that actually all of our solutions for this particular inequality are going to be less than 4. And the way that we get there is if we flip-flop the inequality sign, and we do that anytime we divide by a negative or multiply by a negative. We have to flip the inequality sign to make sure that our solutions that we shade are the correct ones. So, let's put this to practice, right? Number 3. We've got negative x over 4 is less than negative 1. Well, since the fraction bar means division, I've got to do the opposite, which is multiplication, to undo that and isolate that x. Negative 1 times negative 4 is 4. And so now, well, wait a minute. We multiply it by a negative. So you've got to flip the inequality sign. So now x is greater than 4. 0 here. 4 here. Open circle on 4 because the inequality is not equal to, which means that 4 is not going to be a solution. And all of our solutions are indeed bigger than 4, greater than 4, so we need to go to the right. Okay? Try 4, see what you come up with. You can stop the video, start it back up, and see if you're right. Did you get this? Did you get y is greater than or equal to negative 7, and did your graph look like this? Okay. If not, you got to find some help, okay? Now, story problem involving multiplication or division. You walk dogs in your neighborhood after school. You earn $4.50 per dog that you walk. How many dogs do you need to walk to earn at least $75? And we went ahead and defined the variable for you. D is the number of dogs. Okay? Well, we can look at it this way. Your money earned needs to be at least $75. Are you okay if you make more than $75? Sure you are. So our inequality is going to be greater than or equal to $75. Now, how do you figure out how much money you earn? Well, D is the number of dogs. And there's this word per here. You get 450 per dog. Per means multiply. So we're going to take 450 times D and make that greater than or equal to 75. Okay? Divide by 450. And so D becomes greater than or equal to what, 16.7 when you round it, right? Now, you can't walk 0.7 dogs. So what does this mean? This means that you need to walk at least 17 dogs to get at least $75. Okay? Story problem. There you go. Another one. A student club plans to buy food for a soup kitchen. A case of vegetables costs $10.68. The club can spend, at the most, $50 for this project. What are the possible numbers of cases the club can buy? Take a second, try to set that up. Make sure that you define your, well, the variable's already defined for you right here. But set up your inequality, solve it, write out a good sentence answer. Stop the video, and you can always check when you start it back up. Okay, did you get this? 10.68C, we're going to multiply the number of cases times the cost for each case, which is $10.68, has to be less than or equal to $50. Divide by 10.68, and C is less than or equal to 4.68. Now, what does that mean? That means, can we buy 5 cases? Because we rounded up on the last one to 17. Can we buy 5 cases here? No. We can only buy up to 0.6 cases, so 4.6 cases. And we can't buy 0.6 cases. So we can buy 4 cases. That's it. We'll have some money left over, but that's the way it goes. Okay? All right. Now, we're going to add in some multiple steps here, more than one step. And again, this is the same as it was when we were solving equations. We just have to keep an eye out for multiplying or dividing by a negative. So number 7, I'm going to subtract both sides by 9. You get 4t is greater than 21. Oh, 21. 4t is greater than 12. Divide by 4, and t is greater than 3. If we wanted to graph it, and most of the time we will, put 0 here, 3 here. Open circle on 3 because it's not a solution. It's not a solution because the inequality is not equal to. 3 is not greater than 3. So open circle on 3. We want to shade to the right because that's where all of our larger numbers than 3 are. And there we go. Okay? Try 8. Stop the video, try 8, and you can start it back up and see if you're right. Okay, you should have gotten A is greater than or equal to -4. Okay, and if we wanted to graph it, we certainly could. 0 here, 4 here. Close circle on, oh wait, -4. Sorry, -4. Close circle on -4 because -4 is a solution. -4 is equal to -4. And we want to shoot this out to the right because all the rest of our solutions are bigger than -4. Numbers that are bigger than -4. Okay? A couple more here for you. Now the trick with number 9 you need to be careful with, because when we want to solve for v, we want to undo this subtraction by zeroing out the 5. We've got to do that by subtracting 5. When we do, make sure you bring this minus sign down as a negative, -3v. So that now, in order to divide to solve, you have to divide by -3. And so you get 3 is greater than v. Flip the inequality sign. Okay, and I'll leave the graphing for you. I think we're okay there. Try 10. Stop the video. See what you get when you start it back up. And there you go. Subtract the 30. Divide by 0.8. 25 is greater than x. If any of these are giving you trouble, make sure you come see me during STAR. Okay? Some story problems for you. In a community garden, you want to fence in a vegetable garden. that is adjacent to your friend's garden. You have at most 42 feet of fence. What are the possible lengths of your garden? Well, in order to put a fence up, we have to go around the garden, and that's perimeter. And we only have 42 feet of fence, so our perimeter has to be less than or equal to 42 feet. Okay? Well, this is how you find perimeter. So I want to replace that P with 2L plus 2W and make that less than or equal to 42. Now, I don't know how long the fence is going to be. That's what we're being asked. What are the possible lengths of your garden? But since we're going to put our garden right next to our friends, we're going to make sure that the width is the same. And right here, the width is 12 feet. I'm going to come over here and make this 2L plus 2 times 12. That's our width. Is less than or equal to 42. 2 times 12 is 24. Subtract 24. And then divide by 2, and L is less than or equal to 9. So what are the possible lengths of the garden? Well, you can use any length you want in the garden as long as it's 9 feet or less. Okay, so the length can be 9 feet or less. Okay? All right. Along the same lines, you want to make a rectangular banner that is 18 feet long. You have no more than 48 feet of trim for the outside edges of the banner. What are the possible widths of the banner? Okay. It's kind of along the same lines as the last one. Try to set it up with the perimeter formula. See what you get. Check your answer when you start the video back up. Okay, possible widths would have to be 6 feet or less. It's the only way you're going to have enough trim. Okay? All right. Now we're going to add in a little bit of the distributive property when we start to solve these. Again, we did all this with the equation, so hopefully this is just some review. Okay, we're going to distribute this 3 here. So 3t plus 3 minus 4t is greater than or equal to negative 5. Now, we have to simplify the left-hand side before we can solve, which means that we're going to add all of our like terms. I'm going to add 3t and negative 4t. 3t plus negative 4t is negative t. Okay? Then we're going to subtract the 3. And then because the t is still not isolated, it has a negative in front of it, or a negative 1. I've got to divide both sides by negative 1. So now t becomes not greater than or equal to, but less than or equal to 8. We had to flip that inequality sign since it was negative. Okay? And then 14, I'm going to distribute this negative 2. Make sure you do distribute it to both. And take the negative sign, take the minus sign with it as a negative. Negative 2 times positive 7 is negative 14. Now I've got to simplify the right-hand side. I'm going to combine those guys. We get negative 9 minus 8m. Now I'm going to add 9. And then I've got to divide by negative 8. So we get m is... We've got to flip the inequality sign. Make sure you flip that. This is negative 3. So negative 3 is greater than or equal to m. Okay? All right. Now, some special solutions. Watch what happens with number 17. We distribute the 2 here. So 10 minus 8a is greater than or equal to 10 minus 8a. Hey, wait a minute. 10 minus 8a is greater than or equal to 10 minus 8a. Huh. If I were to go ahead and add 8a to both sides, which is what I would do, right? I'm going to collect all the a's on one side. Negative 8a plus 8a is 0. It's not a. It is just plain old 0. So you'd end up with 10 minus 0 is greater than or equal to 10 minus 0, or 10 is greater than or equal to 10. Now, is 10 greater than 10? No. But is 10 equal to 10? Yes. So 10 is always equal to 10. I'm looking for solutions. And solutions are any number I can plug in for A that would make this inequality true. Well, if you look up here, the two sides, the left and right side, are exactly the same. So whatever I decide to plug in for A, the left and the right side will still be the same. And since this is an equal to inequality, that means that this inequality will always be true no matter what I plug in for A. So this is our infinitely many solutions. Right? Good. Now compare that to this next guy, where when I combine like terms here, I get 6m minus 5 is greater than 6m plus 7. Just add the 7m and negative m. Then when I subtract 6m, again that adds to 0, and so I get 7. Adds to 0, I get negative 5. Now I get a statement that says negative 5 is greater than 7. Well, negative 5 is not greater than 7. It never is. So if we go back up one step, that means whatever I plug in for m, this left side will never be greater than the right side. Never. So this is no solution. Since there are no solutions, there's no need to graph it. If we go back, infinitely many solutions, how do you graph that? Well, infinitely many solutions means that no matter what you put on the number line, we're going to shade in the entire number line because everything's a solution. Okay? Got a couple more here. Give them a shot, see what you come up with. Stop the video, start it back up, and see if you're right. Okay, not special solutions this time, but we are talking about having variables on both sides, and it's like an equation. You're going to collect all the variables on one side. So in order to do that, you've got to move them across the inequality sign, which means you are going to have to zero them out on one side. So on number 15, you subtract the 3n from both sides. Then you add the 1, divide by the 3, and n is greater than 3. For number 16, you're going to add the 2b. Then subtract the 12, divide by 5, and b is greater than 3. Okay? And that's it. If there are any questions at all, please come find me. We'll sit down and go through this. Your homework's out in Canvas. Make sure you have that done next time.